Thanks. So my name is Pierre Lison. I'm working in a research institute called Norwegian Central, the Norwegian Computing Center, and I will talk a little bit about use cases. So we've heard from Lilia how these models work from in a general perspective. I will now describe how you can actually, some of the applications that you can have of these models. And I have fewer slides than Lilia. So as Lilia mentioned, and it's perhaps the key point you need to understand, is that large language models are representation learners. They construct vector representations of the texts that they're fed with, and with these representations you can do many different tasks. But they compute representation, contextualized representations of words, phrases, any kind of linguistic units that they're given, and based on these representations, you can then classify, generate, filter, basically anything that you want to do on text data. And so, although the models are initially trained on the task of word prediction, so given a partial text, what is the next word or next token that will come, they can be applied to many other tasks than just word prediction. Which brings the concept of transfer learning, that you can transfer knowledge that is baked in the parameters of large language models onto other tasks. And why would you do that? There are several reasons for that. The first is that it has been shown to be much easier models where you don't have large amounts of training data if you are starting with an existing pre-trained large language model and then fine-tune this language on a task. So you download, for instance, the pre-trained language models for the language of your choice. You fine-tune it, means that you're changing the parameters to optimize your model for the particular task that you have. And then you apply these fine-tuned models for your task, right? So that's one reason that you can actually do what's so-called few shots learning. In some cases, you can even do zero-shot learning, where you can directly apply the model to your task, but very often you want to do some fine-tuning to really get the results that is really optimized for your particular task that you're interested in. And the second argument for fine-tuning existing large language models is that they've been shown to have very good performance if you compare these models, these fine-tuned models, to models that are trained from scratch. So that means that you're starting a model that does not know anything to begin with. And it's also more robust to different kinds of language content. So it's both easier to learn when you have lots of data, and typically we don't have huge amounts of training data, and they generate because they're starting with these general language representations instead of having to start from and having to understand how the particular and grammatical structure of the language works. Because this is something that the language model has already learned and has stored in its parameters. So that's perhaps the most important. So if there was one thing that you need to remember from my presentation here, is that language models are representation learners, and you can fine-tune to different tasks. And now I will describe some of these possible tasks. One could be grouped into the term document intelligence. So the basic idea is to organize documents, and perhaps a very well-known and old application of natural language processing is, of course, classification. Given a text, try to categorize it into a number of labels or categories, such that you can put it in different directories, for instance, or classify your emails according to certain rules. A particular subtask is called filtering, and filtering is binary classification. Either it's spam or it's not spam, but you can do filtering for any kind of task. You can do sentiment analysis, which means extracting the subjective value judgments or judgments from text, for instance, whether a user liked your product or not. And you can do something that has a generic term of information extraction. So information extraction is about recognizing entities and their relations in a text. And typically, when we talk about entities, we talk about named entities. So things like names, dates, organizations, locations, etc. Here is a particular example of named entity recognition, for which you have already pre-trained models. So it's something that you can apply on the fly. It takes 5 minutes, and you will get the result like this. Here it's in English, but you can do that in Norwegian as well. And basically, named entity recognition or any kind of entity recognition is framed as a token classification problem. So the idea is that you're tokenizing your text, you're splitting your document into words or subwords, and then for each of these subwords, you decide that is this part of a particular category I'm interested in, like person, or not. And then it will do the classification for all of these subwords. It will also add some information about whether it's the start or the end of a segment. And based on this token classification, it will then group its token classification labels into segments. And here you go. You have your text bands you're interested in. So from a very simple task like token classification, you can get these segments. And then you can have another part of your model that does relation extraction. And relation extraction is about finding whether, for instance, Pierre, Lison and Norwegian Computing Center have a relation which is one is the employee of that organization. And based on this, you can, for instance, build a knowledge base. You can build a graph showing entities and the relations from your documents. Something else that I'm personally interested in, we have a full research project on, is text de-identification, so removing personal data from text. And that's typically framed as some kind of information extraction problem, where we find text bands in the document that express personal information, relate to an existing individual, and then mask the information so that that personal information is no longer conveyed. So that's the first use case. A second one, which of course has begun very prominent right now, is content creation. Basically, autocomplete on steroids. Try to generate documents based on what we call a prompt, which is the start of either a question or the start of a text that is then generated automatically. It can be used for any kind of writing assistance, grammar checking, stylistic suggestions, how to improve your documents, finding better phrasings for what you want to write. It's not only, of course, for classical text, but it can also be for code. So as you probably heard, GitHub has launched what they call a Copilot, which makes it easier to basically to program efficiently by providing suggestions or auto-completing some of your code. So there it's autocomplete, but for code. And a particular task that language models do quite well is summarization. So providing a short summary of a given text. And for this, you can fine-tune, of course, if your text is very specific, or if you have specific constraints on your summaries. But typically, you can do that zero shot. So language models have already quite good abilities to summarize text. So if you ask ChatGPT to summarize your text, it will do that quite well. Third use case, interactive systems. And ChatGPT, of course, is a prototypical example of an interactive system, and more typically an open-ended chatbot that can talk and answer basically anything. The factuality of its answers is, of course, not always to be trusted, but it can, in theory, answer anything. But very often, for practical uses, you don't want ChatGPT to basically provide answers to anything. If you're a commercial company and you want a chatbot, you want to control what the chatbot understands and answers. And you don't want to lose that control. You want, for instance, if a user asks for opening hours or the employees of your company, you want to be the one in charge of providing the information. But you can use language models to do that. Simply you have to phrase this, for instance, as first understanding intent of the user, finding the state of the dialogue, and then finding the best possible response. And you can fine-tune language models to do exactly that. And different ways of doing this, but you can build interactive systems, so dialogue systems that are oriented towards a specific task. You can also build voice-activated assistants or text-activated assistants, of course, and ChatGPT is yet another example of that. And you can do question answering. So question answering is a type of interactive system where there is a knowledge base, which is in the back end, and is used for extracting the answers. So for instance, here you have question, what is the capital of Germany? And you have a large knowledge base like Wikipedia, for instance, where the answer is. And then the task of question answering is to find the text pads that express the answer and retrieve it. And sometimes rephrase that answer so that it reads well and perhaps combine different information together. So that's another important task of these interactive systems. And there are many others. Of course, a very important one is machine translation, but typically you don't build your own machine translation system, so for a particular use case, it's perhaps a tool that you're using than a model that you fine-tune, but it's of course an important application area, and the same goes for speech processing, where language models are heavily used for building better speech processing models, for recognition, for synthesis, and of course, for better search. You can build better search engines using language models, but typically, you don't build your own search engines if you're not Google. I would like to conclude with some interesting technological developments that are happening right now in the field. The first one is the increased focus on multimodal models. So models that are trained with non-text data alongside text data. You've seen, for instance, DALL-E, which is a model where you can generate image from text. You can do the other way around. You can generate captioning from an image. That's also very useful in many cases. But the basic idea is to build models that are fed with other information than just linguistic inputs. Because a classical language model has never seen anything of the external reality that is described in its huge text corpus, right? It has only seen, well, letters or linguistic symbols of some kind. But if you train these models with images, videos, there's also some very interesting work on training language models with actual physical robots that can interact with their environments, so they can actually get some kind of sensor-motor experience of the world and use that information to build better representations. So that's quite hot right now, and these multimodal models are certainly going to be one of the key research focus of this year. And another development that is also very important is knowledge augmented models. Because as we'll also hear more in the next slides, language models have a big problem with factuality. And it's not only a technical problem, it's really a problem that is about the way these models are built and trained. So how we can build models that are augmented with factual knowledge that we can control, that we can change, that we can verify is another very important focus. And there are different models that are built right now, where instead of training the models on huge corpora and then not being able to do anything with it, we have models that can actually search a knowledge base that can be then updated regularly, that can be controlled, and that form the basis of the knowledge graph of your model. And that's also very interesting and very much an active research area. That's it for me.
Yeah, thank you.
Thank you.